All right, everybody. Let's talk about some trigonometry for your final exam. So we're just going to warm up with some old school SOHCAHTOA, right triangle trig. And remember, to work with right triangle trig, you want to always stand on the angle provided, whether it's a measurement or a variable. So we stand over here, this would be our opposite, this would be our hypotenuse, so we're going to say that the sine of x is equal to opposite over hypotenuse. And this is where your calculator comes in handy. You have to know how to use your calculator. So when you're looking for an angle, you always use the second button, and you always need to be in degrees for these. So you would just press second sine of 5 divided by 15, and you will get 19.5 degrees. Okay? Next example, we're going to stand over here on 72. We have an adjacent and a hypotenuse. So we're going to use the cosine of 72 is equal to the adjacent over the hypotenuse. When x is on top, we need to multiply. So we need to multiply both sides by 32 to get rid of the 32 and get x by itself. So we just type 32 times the cosine of 72, and you're going to end up with 9.9. And finally, the last one, we have an opposite and an adjacent from when we stand at 24. So that's the tangent of 24 is equal to 18 over x. Since x is in the denominator, we need to get him out of the denominator first. So we would multiply both sides by x, then divide by the tangent of 24. So really, you just switch those guys. So x is equal to 18 divided by the tangent of 24, and you will end up with 40.4. Okay? But that's old school stuff. You've seen that before. I wanted to warm up with that so you can work on word problems. So in order to work with a word problem, you have to draw your own picture. So if Joe is at the top of a 100-foot tall lighthouse and looks down at an angle of 65 degrees, angle of depression, and he sees a boat, how far is the boat from the lighthouse? So here's the thing. Angle of depression is 65. Remember, angle of depression would be from his original line of sight. So 65 is actually on the outside of that triangle. That's why we would put it down here, using alternate interior angles. So we can just use, in this case, tangent. We would have the tangent of 65 is equal to 100 over x. Since x is in the denominator, you would just do 100 divided by the tangent of 65 and find out that we are at 47 feet away from the lighthouse. Okay? Next example, very similar with a slight twist. So we're still going to have a right triangle, and we're still going to have 50 foot of string for a balloon, and we still have our angle of elevation, and we're going to find our height. So we still have everything that applies to our right triangle. The only difference is this: it's already 3 feet off the ground. So this pickup truck is already 3 feet off the ground from where they tie the string to. So we're just going to do trigonometry to find x, ignoring the 3. That comes later. So we have the opposite and hypotenuse, so we're going to do the sine of 73 is equal to x over 50. 50 times the sine of 73 in our calculator is going to give us 48 feet. However, we have to add the 3 feet in later because it's already 3 feet off the ground. So you don't want to add it in before because that's not going to help you. It's not part of the triangle. So it is a total of 51 feet above the ground. Okay? Now we're going to switch gears. Now we're going to talk about angles in standard position. So this has been useful for many different things. Now there's a lot of different things we can do with them, but we're just going to graph it, then state some positive and negative coterminal angles, and we're also going to find the reference angle. So 140 degrees, remember this is the positive direction, 90, and then we have to go a little bit past it. And that's how we draw our angle. And you also need to put an arrow on your trailer. But this is what you want to ask yourself. Remember, reference angles are always how far you are away from your x-axis. So you've gone 140, how far are you from 180? Your reference angle is 40 degrees. Now, positive and coterminal and negative coterminal, those are simple. You just have to add 360 or subtract 360 from the original till you find a positive or a negative. So in this case, you would have negative 220 for a negative one, and you would have 500 for a positive one. Now, of course, there's more. You can add 360 10 times if you want to. As long as you just keep on adding or subtracting 360, those are all coterminal angles. There's an infinite amount of them. Number 7, 5 pi over 4. So remember, this over here is pi, and this is 2 pi. So 5 pi over 4 would be 1 1/4 pi. So we still have to go a full pi, and then we just go a fourth of another one. Now, again, reference angles are always how far you are. So we went 5 pi over 4, which is pi over 4 away from pi. So our reference angle is pi over 4. Now, for positive and negative coterminal angles, we're not going to add and subtract 360. We're going to add and subtract 2 pi. So if we do 5 pi over 4 minus 2 pi, you'll have a negative 3 pi over 4 coterminal angle. And if we were to do 5 pi over 4 plus 2 pi, we would end up at 13 pi over 4 coterminal angle. So again, same concept, you just have to make sure you're in radians. Last example, a negative angle means we go clockwise instead. So we're going to go negative 150 degrees, which means we are 30 degrees away from getting to negative 180. Now notice how I didn't say anything about our negative reference angle. Reference angles are always positive. So we have a 30-degree reference angle. And just like the first example in this, we would add and subtract 360 to get our positive and negative coterminals. So you should have an example of negative 510 degrees, 210 degrees, or anything adding and subtracting 360 to those as well. Okay? So the reason we did all of that graphing and reference angles is so we can get to the unit circle. Now, on your final exam, you'll have a note sheet that's going to have a unit circle, but you are going to have to memorize quadrant 1. Telling you right now, you have to memorize quadrant 1. But in order to answer the questions, you could always check with your calculator. So you could type cosine of 120, and it's going to tell you it's negative 0.5. So we already know that this is negative 1/2. Obviously, you have to make sure that you're in degrees. But to do this with the unit circle, remember, negative or positive 120 degrees has a 60-degree reference angle. So on our unit circle, remember, you were told to memorize quadrant 1. The coordinates 60 degrees had a 1/2 comma √3 over 2 coordinate. So if you have that memorized, a 60-degree reference angle is still going to have a 1/2 x value. The only difference is we're on the left side of the y-axis, so that's where x values are negative. Okay? Sine of negative 3 pi over 4, you could type it into the graphing calculator, this time in radians, of course, and you would get a decimal. So again, you have to know the unit circle. Negative 3 pi over 4 has a pi over 4 reference angle. So the sine of pi over 4 is the square root of 2 over 2. But since we're down here, we have a negative square root of 2 over 2 for our angle. Now I bet you if you type negative square root of 2 over 2 in the calculator, you would get the same decimal value as sine of negative 3 pi over 4, as long as you are in radians, of course. So the last one, 5 pi over 3, we're going to take the tangent of it. 5 pi over 3 would be almost a full circle, so we are down here. Remember that follows the rules of sine, so sine is negative down here. So pi over 3, the reference angle, is the same as 60, but we would have the square root of 3 for tangent, because tangent is sine divided by cosine. Or again, you can memorize quadrant 1, and you would end up with negative square root of 3 for tangent down here. And again, you can always check with your calculator. If you're in radians, make sure your calculator is in radians. If you're doing degrees, make sure your calculator is in degrees. Okay? Now, inverse trig. This is what I was talking about back in class, how you guys could just use your calculator. all you have to do is make sure your calculator is in degrees. Now watch this. Take your calculator and press second sign, and a sign -1 will pop up, and type the square root of 2 divided by 2 in the calculator. If you have an older calculator, it'll look like this. Sign of -1, the square root of 2, close the parentheses, then divide by 2 and close the parentheses again. You've got to make sure you type it in correctly, but the crazy thing is your calculator is just going to spit out 45. So you know it's 45 degrees. Now just divide 45 by 180 in Math Fracket, and you're going to end up with pi over 4 for your radian measure. Your calculator can do inverse trig no problem. So make sure you know how to use your calculator. Cosine. Press second cosine of -1/2. Second cosine of -1/2 is going to tell you it's 120 degrees. And then just divide that by 180. Math Fracket, you get 2/3, so you get 2 pi over 3 for your radian measure. And finally, you would do the exact same thing for the last example. Second tangent of the square root of 3. You'll end up with 60 degrees. Divide that by 180 and change it to a fraction, and you will have pi over 3. Okay, so all of that can be used to help you evaluate trig functions. We're going to wrap up with coordinate trig and graphing. So coordinate trig is very important to draw the graph first. So we know that -15, 8 would be a -15 along the x-axis and up 8. So we would have a triangle that looks a little bit like this. Now remember, your reference angle always goes by the origin. So this is -15, this is +8, and then we just have to do the Pythagorean theorem. We would just have 8 squared plus a -15 squared is equal to c squared, and you will end up with a c value of 17. So the hypotenuse is 17. So now to state sine, cosine, and tangent, it's just sine of theta is equal to opposite over hypotenuse, it's 8/17. Cosine of theta is equal to adjacent over hypotenuse, which is -15/17. And tangent of theta is opposite over adjacent, so that would be -8/15. But you have to just find the hypotenuse first. So in the second example, we would do the exact same thing, but we would go to +7, -24, and we would always draw our reference angle to the x-axis. And we have a +7 for x, a -24 for y. This time, if you do the Pythagorean theorem correctly, you would get 25 for your hypotenuse. Now, the hypotenuse is always going to be positive. We don't ever have a negative hypotenuse. So, just go stand on your reference angle. So, sine of theta would be opposite over hypotenuse, which would be -24/25. Cosine of theta would be adjacent, so 7/25. And finally, tangent of theta would be equal to the opposite over the adjacent, -24/7. And if you go back and think about the unit circle, remember we always talked about sine is y and cosine is x, and tangent is sine divided by cosine. So if we know this is cosine and we know that this is sine, then sine divided by cosine is -24/7. See? I was never lying to you. Okay? Last two examples are on graphing. So let's talk about graphing. Period. It's always 2 pi divided by b. So, well, there's no b value. So our period is just 2 pi. Our interval is always the period divided by 4. So our interval is going to be pi over 2. Now the only thing we do with the interval is just list them on the tick mark. So we have pi over 2, pi, 3 pi over 2, and 2 pi. Remember, your fourth tick mark should always be your period. And then, of course, that's the same thing for going backwards. Our amplitude is 2, because that's the number in front. Our horizontal shift is pi over 2 to the left. So we have pi over 2 left. We don't say negative, we just say pi over 2 left. And our vertical shift is not +3, it's 3 up. We have to state directions. So a vertical shift of 3 up, we would just go up 3, and we would put our horizontal dashed line. Our amplitude of 2 means we would put a line 2 below our vertical shift and 2 above our vertical shift. And then we have a horizontal shift of pi over 2 to the left. That's one tick mark to the left. And we draw a vertical line. So the last thing we have to do is ask what it is. This is a positive sign. So positive signs and negative signs will always start on the middle line, but a positive sign will go up as you go to the first step to the right. And then, of course, we just follow the pattern, always hitting the node before we get from the top to the bottom. In backwards direction, we just make sure we continue going, following the pattern. And there you go. So then you would just graph a little sine wave, and you're good. Okay? So our last example here. We have 2 pi divided by 1/2 for our period. So our period is 4 pi. Divide that by 4 and you get an interval of pi. So pi, 2 pi, 3 pi, 4 pi. Our amplitude is 3. Our horizontal shift is 2 pi to the right. Our vertical shift is 1 down. So we have our 1 down. We have our amplitude of 3, so 3 below that and 3 above that. We have our horizontal shift of 2 pi to the right. So the last thing you have to do is ask yourself is, what kind of a trig function? It is a negative cosine. Cosine starts at the top or the bottom. When it's negative, it starts at the bottom. Positive starts at the top. So here you go. Follow your pattern. Always hit the node before you get from one to the other. And finally, you are done. Just connect your dots. Make sure you're swooping. Sine waves are curved. They're not straight lines. And we're good to go. That's it for your trig review. This is Longo and I'm out. See you, bye.